imagine, for a moment, the slow turn of our blue planet as seen from far above the clouds. Before we go any further, if you want a brand new Earth topic every single night to fall asleep to, subscribe. One tap and a new story is waiting for you every evening. From that quiet height, Earth looks finished. It looks complete. The 7 familiar continents drift in their slow, patient places, ringed by the deep blue of the oceans. The white swirl of weather moves across them. The ice caps glow at the top and the bottom. It is the picture we all carry in our minds when we think of home. But the picture is not the whole story. Beneath those calm blue surfaces, hidden under thousands of feet of dark, cold water, there are other continents, ghost lands, pieces of crust that once stood in the sun, held forests or shallow seas or strange ancient creatures, and then quietly slipped beneath the waves. Some sank slowly over many millions of years. Some were torn apart by the patient pull of moving plates. Some were buried by younger rock, hidden under the mountains we hike on today. Tonight, we are going to sit with a very old and very gentle question. How many continents has Earth truly had? And how many of them are still down there, waiting in the dark, mostly unseen and mostly unknown? Let your eyes soften. Picture the western edge of the Pacific Ocean, where New Zealand rises in a thin green curve. For a long time, geologists thought New Zealand was simply a chain of islands, just a scatter of high ground above a deep sea. Yet, in the last few years, careful mapping has shown something stranger. New Zealand is not really a set of islands at all. It is the small, dry crown of a much larger landmass, a continent called Zealandia. Most of it sits about a mile below the surface of the sea. Only its highest peaks break the water. The rest is a vast, drowned country of rolling submarine plains and broad ridges, almost as wide as the contiguous United States. That alone is enough to make the mind pause. An entire continent, hiding in plain sight, finally accepted in the scientific literature only in the last decade. And if Zealandia could remain unseen for so long, then a quiet question begins to glow at the edges of our thinking. What else has Earth tucked away beneath its blue? Move your gaze west. Picture the warm waters of the Indian Ocean, the long, pale beaches of Mauritius, the green slopes of Reunion. Beneath these young volcanic islands, researchers have found grains of a much older mineral called zircon. Tiny crystals, billions of years old, far older than the islands themselves. Some scientists believe these grains hint at a sunken sliver of ancient continent, sometimes called Mauritia, buried under the lava. Others wonder if the zircons traveled there by some other path, swept in by ocean currents, or carried by drifting volcanic dust. The question has not been closed. Drift north now over the soft hills of Italy, the dry mountains of Greece, the limestone shores of Croatia. Hidden under all of them, smeared and folded into the rock beneath Europe, lies the squeezed remains of a lost continent called Greater Adria. It did not sink. It collided. Its surface was scraped off and crumpled upward into the mountains that hikers climb on quiet mornings. Its deeper body slid down into the hot interior of the planet. Some of what was once a sunlit coast is now stone in the Apennines. Some of it may be melting still far below. And there are more. There is Argoland, a long puzzle piece that broke away from Australia and seemed to vanish from the map. There is the drowned shelf of Doggerland, which once held forests and rivers between Britain and the European mainland. There is Beringia, the broad, cold plain that linked Asia to the Americas. There are deeper, older gatherings of land called Rodinia and Kenorland, whose shapes we can only guess at from clues in the oldest rocks. We will visit each of them slowly in the hours ahead, not as a list, but as a long, calm walk through a question that scientists are still trying to answer. How complete is our map of Earth? How many lost continents lie beneath us, under the dark water, under the young mountains, under the slow rivers of the Mantle? The honest answer for now is that we do not know. We are still listening. We are still mapping. The planet is still revealing itself to us, one quiet hint at a time. The word lost is a funny one when we use it to talk about continents. A set of keys can be lost. A letter in the mail can be lost. But a continent is a piece of Earth itself, hundreds of miles wide, made of stone older than almost anything else on the planet. So What does it mean to lose something so vast? To understand the mystery, we first need to settle on what we are even looking for. A continent, in the simplest terms, is a large block of light rock that floats on top of heavier rock below. Imagine a slice of bread resting on a thick pot of warm soup. The bread is lighter, so it sits on the surface. The soup beneath it is denser, hotter, and slowly moving. Earth works in much the same way. The bread is the continental crust. The soup is the mantle, that deep layer of slow-flowing rock that holds the continents up. Continental crust is usually between 20 and 40 miles thick. That may not sound like much, but think of it this way. If you drove straight down at highway speed, you could pass through the entire crust in less than an hour. And yet, that thin skin is what we live on, what holds our forests and rivers and cities and quiet sleeping towns. Ocean crust is different. It is thinner, only about 4 miles thick, and made of heavier, darker rock. This is why oceans sit lower than continents. The light continental rock rides high. The dense ocean rock rides low. Water simply fills in the gaps between. So when geologists talk about a lost continent, they usually mean a slab of that lighter continental rock that no longer stands above the waves. It may have sunk. It may have been stretched thin and pulled apart. It may have been crushed into another continent and folded up into mountains. Or it may simply be hiding under the sea, with only a few small islands poking above the surface to hint at the giant beneath. The size of these hidden lands can be hard to picture. Zealandia, the one many researchers now call our 8th continent, covers nearly 2 million square miles. That is about the size of the Indian subcontinent. It is more than 3 times the size of Texas. And yet, roughly 94% of it lies underwater. New Zealand and New Caledonia are the small, dry corners. The rest is drowned plains, ridges, and slopes hidden beneath a mile or more of dark seawater. Age is the next thing to settle in your mind. Continents are old. Most of the rock that makes them up is hundreds of millions, even billions of years old. Some grains of mineral inside continental rock have been dated to more than 4 billion years. That is nearly as old as Earth itself. So when a continent appears to vanish, the rock does not really vanish. It just moves or sinks or hides. Stone has a long memory. The slowness of all this is the part that is hardest to feel. Continents move at roughly the speed your fingernails grow, about an inch or two each year. That sounds tiny, but across 100 million years, an inch a year becomes more than 1,500 miles. Enough to open an ocean, enough to close one, enough to drag a continent across the face of the world and bury it under another. There is another kind of lost worth mentioning. Some continents are lost not in space, but in our records. They existed long ago, broke apart, and the pieces scattered into other lands. The clues are still there, locked inside rocks on different shores, but the original shape is gone. Reading those clues is a little like trying to reassemble a single torn page from scraps stored in 100 different libraries. How many of these vanished lands are out there? No one can say for sure. We have confirmed a few. Zealandia, with its broad, submerged shelf. Greater Adria, pressed beneath southern Europe. Mauritia, hinted at by ancient grains found on young volcanic islands. Argoland, whose pieces still puzzle the people who study them. Each one was unknown not long ago. Each one was hiding in plain sight. The basic picture, then, is this. Earth's surface is a slow puzzle of light blocks drifting on heavier rock, sometimes rising into mountains, sometimes sinking under the sea, sometimes torn into ribbons and scattered. Some of these blocks we have named and mapped. Others, perhaps many others, still wait quietly under the water or under our feet. The question of how many remain is one we will sit with all night long. To understand how a continent can be lost, we have to first understand how a continent comes to be at all. And that story begins long before any land had a name, long before any sea was named, when the young earth was still cooling from its fiery birth. The surface back then was not the calm patchwork of shores and stones we know today. It was a churning skin of molten rock, slowly hardening into a thin shell as the heat of the planet leaked out into the dark. Out of that early skin, the very first continents formed. They were small at first, just rafts of lighter rock floating on heavier rock beneath. These rafts were granite-like, pale and buoyant, and they bobbed gently on the denser, darker stone of the mantle below. The mantle, that thick layer of hot rock between the crust and the core, moves very slowly, like warm honey poured over a winter stone. And as it moved, it carried the early rafts with it. This is the slow dance we still see today. The plates of the earth's crust ride on the mantle's quiet flow. They drift, they collide, they pull apart, they grind past each other along long, hidden seams. Some travel only a few centimeters a year, about the rate your fingernails grow. Yet given enough time, even that gentle pace can carry a continent across half the world. How long did this dance take to begin? That question is still open. Some researchers believe the first real plates began moving around 3 billion years ago. Others think the process started earlier, perhaps 4 billion years ago, when the crust was barely formed. A few suggest plate tectonics, as we know it, did not truly begin until much later, maybe only 1 billion years ago. The evidence is faint, written in tiny crystals called zircons, grains so small you could hold thousands in the palm of your hand. These crystals carry chemical hints of ancient pressures, but their language is hard to read. The question of when the dance began remains beautifully unsettled. What we do know is that once the plates started moving, the surface of the earth was never still again. Continents grew larger by gathering up smaller fragments. Volcanoes added fresh rock along their edges. Oceans opened where the crust pulled apart, and oceans closed where the crust pushed together. Whole seas were swallowed back into the mantle, melted down, and recycled into new stone. This is the strange truth at the heart of our mystery. The earth does not preserve its past the way a museum preserves an artifact. It melts its past. It buries it. It folds it back into itself. A continent can be born, drift for hundreds of millions of years, collide with another continent, fracture into pieces, and then sink quietly beneath the waves. The dance is not gentle on those who join it. Picture the slow choreography. A wide, flat slab of granite rides across the mantle, carrying its mountains and its rivers, and its young forests on its back. Far away, another slab moves toward it. They meet slowly, over tens of millions of years. The collision pushes some rock skyward, building new ranges. Other rock is shoved downward, sliding beneath the heavier plate, vanishing into the hot dark below. And along the seams, smaller fragments break off. They drift on their own paths. Some end up stranded in odd places. Some sink. Some are buried under newer continents and forgotten. Each of the lost continents we will visit in this episode was shaped by this slow dance in its own way. Zealandia stretched and thinned until most of it slipped beneath the Pacific. Greater Adria was pushed under Europe and folded into the mountains of southern Italy. Mauritia broke apart as India tore away from Africa and drifted north. Argoland is so badly scattered that researchers are still trying to figure out where its pieces went. Behind all of them lies the same patient force. Heat rising from the core, rock flowing in the mantle, plates riding above, drifting, breaking, healing, and breaking again. The cycle has been turning for billions of years, and it is still turning beneath your feet right now, at the speed of a growing fingernail. Some scientists believe Earth is the only planet in our solar system where this dance happens at all. Others wonder if it once happened on younger worlds and then stopped. The answers lie buried in places we cannot easily reach. For now, we simply know that the slow drift of plates is the great sculptor. It builds continents, and it takes them away. And in its long, quiet rhythm, the lost lands we are searching for were both born and lost. Most of us have heard the name Pangaea. It is the great supercontinent that gathered all of Earth's land into a single shape about 300 million years ago. Picture it from above in your mind. A vast pale mass surrounded by one enormous ocean. The shape curls like a soft letter C, with the warm sea called Tethys tucked into its eastern bay. Forests of strange tree ferns covered its lowlands, and deserts spread across its dry interior. Pangaea is the one supercontinent almost everyone remembers. But it was not the first. It was only the most recent in a long, slow rhythm. Before Pangaea, there was Pannotia. And before Pannotia, there was Rodinia, and before Rodinia, deeper still, there may have been Columbia and Kenorland and older shapes whose names are only quiet guesses. Each one gathered, then broke, then drifted, then gathered again. The earth seems to breathe in this slow way, over hundreds of millions of years. The materials that built these lost continents came from places stranger than the continents themselves. The rock beneath your feet is mostly made of silicon, oxygen, aluminum, iron, calcium, and a handful of other elements. Silicon and oxygen lock together into tiny crystals called silicates. These are the grains in granite, the flecks in sand, the shimmer in a polished countertop. They form the bones of every continent that has ever existed. Yet none of these elements began on Earth. Long before our planet existed, they were forged inside ancient stars. When those stars grew old and collapsed, they scattered their elements across vast clouds of dust and gas. Our young Earth gathered itself from that drifting debris. The iron at the heart of our planet, the iron that gives Earth its magnetic field, was made in the burning cores of stars that died before the sun was born. Every continent, lost or living, carries that older memory in its minerals. Water has a similar strangeness about it. Some of the oceans that once washed against Pangaea's shores may have arrived in tiny pieces, riding on comets and water-rich asteroids in Earth's earliest days. Other water may have been locked inside the planet from the very start, sweated out slowly by volcanoes over billions of years. Researchers still debate the balance between these two sources. The honest answer is that we do not yet know exactly how the seas were filled. When Pangaea existed, those seas circled it in a single great ocean called Panthalassa. The shallow Tethys Sea pressed into its eastern side, warm and full of life. Coral reefs grew there. Strange marine reptiles glided through its blue water. Tiny shelled creatures lived and died, and sank to the seabed in countless numbers. Their shells, made of calcium carbonate, piled up into thick layers of limestone. Much of that limestone now sits high in mountain ranges, far from any ocean, raised up when continents collided. The gases of Pangaea's sky were not quite the same as ours. Oxygen levels rose and fell across deep time. Carbon dioxide was higher during some long stretches, lower during others. The atmosphere itself has shifted in composition again and again. Lost continents lived under skies that we would barely recognize, breathed on by volcanoes, scrubbed by rain, refreshed by plants that no longer exist. Before Pangaea came Rodinia, which gathered about 1 billion years ago. Before Rodinia, the picture grows hazy. Some researchers propose a supercontinent called Columbia, sometimes called Nuna, around 1.5 billion years ago. Others suggest an even older one called Kenorland, perhaps 2.5 billion years back. The evidence comes from tiny crystals of zircon found in ancient rocks. Zircons are stubborn little timekeepers, and they carry chemical fingerprints of the worlds they were born in. By comparing zircons from different continents, geologists try to match up land that once sat side by side. The matches are real, but they are also incomplete. Two researchers can look at the same zircon data and draw two different supercontinents. One reconstruction shows the old lands clustered near the equator. Another shows them gathered near a pole. The shapes shift depending on which clues are weighted most. Earth keeps its older secrets close. The whispers before Pangaea remind us that lost continents are not only the drowned ones beneath today's oceans. They are also the older shapes that broke apart so long ago that even their outlines have softened in the rock. Every grain of sand on every beach carries some piece of those older worlds. The wind has been shuffling that ancient dust for a far below the southwest Pacific, beneath waves that glitter blue and gray. A vast slab of continental rock lies hidden in the dark. We have given it a name. We call it Zealandia. Most of it sleeps under more than 1 kilometer of seawater. Only its highest peaks rise above the surface, and we know those peaks by warmer names: New Zealand, New Caledonia, a scattering of small islands that look, from above, like the tips of mountains poking through a long blue cloth. Zealandia is roughly 5 million square kilometers of crust. That is about half the size of Australia. For most of human history, no one knew it was there. The forces that pulled it down beneath the waves worked far too slowly for any human eye to follow. Yet those forces are not gentle. They are some of the strongest in the planet's quiet machinery. To understand the riddle of Zealandia, we have to picture the slow tug of heat deep within the earth. Below the thin crust lies the mantle, a thick layer of hot rock that flows like soft clay over long ages. Heat from the planet's core stirs the mantle in slow loops. These loops press up against the crust from below. In some places they lift it. In other places they drag it sideways. Where they pull hardest, the crust thins, like soft dough stretched between two hands. That stretching is what most researchers believe shaped Zealandia. Around 80 million years ago, the great supercontinent of Gondwana was breaking apart. Australia drifted one way. Antarctica drifted another, and a long ribbon of crust between them began to thin and stretch. As it thinned, it grew lower. The ocean came in and covered most of it. The land did not sink because anything pushed it down. It sank because it became too thin to stand high. Continental crust normally floats on the mantle the way a thick log floats on water. The thicker the log, the higher it rides. When stretching makes the log thinner, it rides lower. Zealandia is real continental crust, made of the same lighter rocks as the dry parts of the world. It is just thinner now than the continents we walk on. So it floats, but only just. Its shoulders are below the waves. That is one theory of the forces at work. But the story is not closed. Some researchers wonder whether stretching alone can explain how deeply Zealandia sits. Other ideas point to dense currents in the mantle that may have tugged the crust downward from below. A slow suction that thinned it further. Still, others suggest that ancient slabs of old ocean floor, sinking back into the mantle nearby, may have changed how heat moved under the region. Each of these forces, on its own, could shape a continent. Working together, they might shape something stranger. There is also the matter of why Zealandia counts as a continent at all. For a long time, geologists treated it as a collection of broken pieces, simply leftovers from Gondwana's breakup. Then careful mapping showed something different. The crust beneath the sea was connected. It rose as one broad rise from the deeper ocean floor. It had its own clear edges. It carried its own old rocks, some far older than the breakup itself. In 2017, a group of researchers argued that Zealandia met every quiet test of being a continent. The world's 8th continent had been hiding in plain sight under the water the whole time. Even now, the maps remain rough in places. The deep sea is hard to study. Sonar pings can take years to cover even small patches. Gravity readings from satellites can hint at the shape of the crust below, but they cannot show the fine details. So Zealandia is partly known and partly guessed. Its mountains, its old volcanic ridges, its sediment-filled basins are still being charted slowly, season by season, ship by ship. And the deeper riddle remains. If a continent half the size of Australia could escape our notice for so long, what else might the ocean cover? The same forces that thinned Zealandia have surely worked in other places, in other ages. Heat from below, stretching from the side, the slow tug of sinking slabs. These forces do not stop. They are working tonight somewhere on rock so deep no human will ever see it, pushing, pulling, lowering, lifting, shaping the next lost continent in a process measured not in years, but in tens of millions of them. For now, Zealandia rests, mostly drowned, mostly quiet, mostly waiting to be mapped. The forces that hid it are the same forces that may, one day, lift it back into the light. Tonight, let us sit with the scale of what lies beneath the Indian Ocean. The numbers are large, and they grow stranger the longer you hold them in mind. The Indian Ocean covers about 70 million square kilometers of Earth's surface. That is roughly 20% of all the water on the planet. A slow blue plain stretching from the eastern shores of Africa to the western coasts of Australia. Somewhere beneath that vast, quiet, broken pieces of old continents are believed to rest, scattered like forgotten bricks on the floor of a flooded room. To picture the scale, imagine standing on a beach in Madagascar and looking east. The horizon ends a few kilometers away, where the curve of the planet hides everything beyond. But the ocean keeps going, mile after mile, for nearly 6,000 kilometers before it touches the western shore of Sumatra. That distance is longer than the width of the United States. Across that whole stretch, the average depth of the water is close to 3,800 meters. If you could stand a stack of the world's tallest buildings on the seafloor, the topmost roof would still be hidden under more than 2 kilometers of dark water. Now shrink the planet down for a moment. Imagine Earth as a smooth ball, the size of a large beach ball, about half a meter wide. At that scale, the deepest trenches of the Indian Ocean would be shallow scratches less than a millimeter deep. The whole layer of water, every wave and every current, would be no thicker than a sheet of paper wrapped around the ball. And yet inside that paper-thin film, entire pieces of ancient continent are thought to lie quietly, drifting nowhere, waiting to be found. The fragments researchers have proposed beneath these waters are not small. One candidate, sometimes called Mauritia, is believed to stretch across an area perhaps the size of present-day Japan. Another submerged plateau, the Mascairn Plateau, runs for roughly 2,000 kilometers along the seafloor north of the island of Mauritius. That is about the same length as the entire chain of the Rocky Mountains. If it were lifted above the waves tomorrow, it would be one of the longer landforms on the planet. Instead, it rests under 1 or 2 kilometers of water, invisible from any ship that passes above it. The ages involved press the imagination even harder. The grains of mineral called zircon, found on the beaches of Mauritius, have been dated to nearly 3 billion years. 3 billion. A number so large it almost loses meaning. To feel it, picture the entire history of human civilization. Every pyramid, every cathedral, every city ever built, compressed into a single second. At that speed, 3 billion years would still take you about half a year of continuous counting. Those tiny crystals, smaller than a grain of sand, are thought by some researchers to be remnants of a continental crust far older than the volcanic island that now carries them. The temperatures down there are another quiet wonder. At the seafloor in much of the deep Indian Ocean, the water hovers near 2 degrees Celsius, cold enough to numb a hand in seconds, yet steady, almost unchanging, for thousands of years at a time. pressure at 3 kilometers down is about 300 times the pressure you feel at the surface. A human body would not survive a single breath at that depth. Yet the stones rest there comfortably, as they have for hundreds of millions of years. The mystery is how much of this hidden material is truly continental, and how much is simply thickened ocean crust dressed up in misleading clues. One view holds that fragments like Mauritia are real splinters of older landmasses, torn away when India drifted north toward Asia. Another view suggests that some of these features are volcanic plateaus built up from below, carrying ancient sediment but no true continental heart. The evidence comes in slowly, one drill core, one seismic line, one zircon grain at a time. A single research voyage may map only a few hundred square kilometers in detail. The Indian Ocean holds room for thousands of such voyages before the picture becomes clear. So the scale of the question is not just spatial. It is also a scale of patience. We are asking a very slow planet to reveal a very old secret, using tools that work meter by meter across an ocean that is wider than some continents. Tonight, somewhere east of Madagascar, the cold water holds its stones in place. They have waited 3 billion years. They can wait a little longer while we wonder, quietly, what they truly are. Imagine for a moment that you could lift the warm blue waters of the Mediterranean Sea like a thin blanket and set them gently aside. The sun would still be shining. The air would still smell of salt and pine, but the floor beneath would no longer be a floor. It would be a country, a long, pale country, sleeping under the sand and limestone, stretching from the boot of Italy down through the Adriatic, across into Greece, and curving toward the dry hills of Turkey. This is the shape of Greater Adria, a lost continent hidden in plain sight beneath some of the most familiar coastlines in the world. If you could stand on its ancient surface, around 140 million years ago, you would not have seen mountains. You would have seen a warm, shallow sea spread over a low, broad landmass. Pale shoals of coral, wide lagoons the color of weak tea, white sand flats baking under a tropical sun, small, low islands scattered like crumbs across the water, fringed with green palms and cycads. The light there would have been bright and watery, like the light inside a swimming pool. The sea would have been bath-warm, full of tiny shelled creatures drifting through the shallows. That long, low world is the surface researchers now believe lies pressed and folded inside the rocks of southern Europe. Most of Greater Adria did not sink straight down. It slid very slowly beneath another plate. As it slid, its upper layers were scraped off like the skin from a soft fruit. Those scraped off layers were crumpled, lifted, and stacked upward. Today, those stacks are the limestone cliffs of the Dolomites in northern Italy, the white stones of the Apennines, the dry ridges of the Balkans, the islands of Greece. The pale stone you might run your hand along in a Tuscan village square may once have been the sunlit floor of a tropical lagoon. Geologists have spent decades piecing this surface back together. They study the way the rocks bend. They measure tiny magnetic clues frozen inside the stone, which point like compass needles to where each piece once stood. They follow fossils of small sea creatures called foraminifera, no bigger than grains of sand, whose shells tell them the age and depth of the water where the rock was born. From all of this, one team published a careful reconstruction in 2019, showing Greater Adria as a single, long, mostly drowned landmass that broke away from North Africa and drifted slowly north until it met Europe. Yet even this careful map is still open to question. Some researchers wonder whether Greater Adria was truly one continuous block, or whether it was a chain of smaller fragments separated by narrow seas, like a string of soft beads. Others ask how much of its original surface still survives at all. When a continent is dragged beneath another plate, much of it is carried deep into the hot mantle and lost. The stones we see in the mountains may be only the top skin, a thin scraping of what was once a far broader country. The deeper body, the heart of Greater Adria, may already be gone, melted back into the slow currents of rock far below. So when you look at a photograph of a quiet Italian hillside with its olive groves and weathered farmhouses, you may be looking at the rumpled surface of a place that no longer has a name on any modern map. The pale boulders in a Greek field the high, dry passes of Albania, the fossil-studded cliffs above an Adriatic beach. All of these are pieces of a lost surface, lifted into the air by the slow press of one plate against another. What that surface fully looked like in all its detail remains an open question. We have only fragments. We have the broad shape and a few good guesses about the climate and the small, hard shells of creatures that lived in its shallow seas. We do not have its rivers. We do not have its forests, if it had any. We do not know exactly where its shorelines ran from year to year, or how high its tides rose, or what colors its sunsets held over those warm, quiet lagoons. It is strange to think that an entire continent can hide inside the scenery of a vacation postcard. Stranger still to think that travelers walk across the bones of Greater Adria every day without knowing. The lost world is not far away. It is underfoot. It is built into the walls of old churches and the steps of harbor towns. And somewhere inside its pale stones, the memory of a sunlit, shallow sea is waiting, patient and silent, for someone to read it. Tonight we sink a little deeper. We leave the bright surface of the map and slide down into the warm darkness of the Indian Ocean, into a place where the seafloor holds an old, quiet secret. The water above the island of Mauritius looks like any other tropical sea. Turquoise near the shore, deep blue further out, white sand on the beaches, soft as flour underfoot. The island itself is young, formed by volcanoes that began erupting only about 9 million years ago. By the slow clock of the earth, that is barely a heartbeat. And yet, when researchers picked up the sand on those beaches and looked closely, they found something that should not have been there. Inside the grains were tiny crystals called zircons. Zircons are stubborn little minerals. They form deep in the roots of continents, and they survive almost anything. Fire, pressure, the long grinding of rivers. Zircons just keep going. They also carry a kind of built-in clock. Trapped inside each crystal are traces of uranium, slowly turning into lead, tick by tick, atom by atom. By measuring that ratio, scientists can read the crystals age the way you might read the rings of a tree. The zircons in the Mauritian sand came back with ages of 2 billion years. Some were even older. That is far, far older than the volcano they were sitting on. The island itself simply could not have made them. So where did they come from? One idea, the leading idea, is that they came from below, that under the young lava of Mauritius lies a much older piece of continental crust, a fragment of an ancient land hidden beneath the seafloor, pushing tiny grains of its memory up to the surface through volcanic eruptions. That hidden fragment has been given a name, Mauritia. The theory goes something like this. Long ago, perhaps 200 million years in the past, India and Madagascar were joined together as part of a larger landmass. As the continents began to pull apart, the rifting did not happen cleanly. It tore unevenly, like a piece of old cloth, leaving thin shreds and slivers behind. Most of those fragments slipped beneath the rising sea. The thinnest pieces sank. The thicker pieces became islands, and one ribbon of old continent, the idea suggests, was left stranded beneath what would later become Mauritius, and a string of underwater plateaus across the Indian Ocean. Places with quiet names like the Saya de Malha Bank and the Nazareth Bank. If Mauritia is real, it is a ghost continent, not a sunken Atlantis with palaces and roads. Just stone, just an old slab of crust, drowned under younger lava and warm sea, sleeping in the dark. But not every researcher agrees. That is the part worth sitting with tonight. Some scientists wonder whether the zircons might have arrived by another path entirely. Perhaps they were carried in by winds blowing dust from distant continents. Perhaps they hitchhiked in the ballast of ships, or in coral fragments, or in sediment swept across the ocean by ancient currents. The grains are so small, and the world is so well mixed, that contamination is genuinely hard to rule out. So the debate continues, gently, the way scientific debates often do, with more samples, more cores, more careful measurements. What makes the Mauritia question so beautiful is its scale. We are talking about a possible continent, a piece of land the size of a small country, hiding under more than a kilometer of basalt and water. And the only evidence we have for it so far is a handful of crystals smaller than a grain of salt, the story of an entire lost world, written in dust. Other lines of evidence have begun to whisper in the same direction. Gravity maps of the Indian Ocean show subtle bumps and dips that suggest thicker crust in places where the seafloor should be thin. Seismic waves passing through the region behave a little oddly, as if they are crossing something denser, older, more continental than the surrounding ocean floor. None of this is proof. It is just a pattern of soft clues, all pointing towards something that might be there. So the question remains open. Is Mauritia a real lost continent, drowned and forgotten beneath a young volcanic skin? Or is it a beautiful illusion, stitched together from grains that traveled farther than we realize? The deeper you go, the harder it is to be sure. And perhaps that is the gift of these depths, not the answer, but the slow, patient wondering. Somewhere below the warm water tonight, ancient stone may be holding very still, keeping its long secret while the tide moves softly above it. Iceland sits in the cold North Atlantic, a place of black sand, green moss, and slow steam rising from cracks in the rock. To most travelers, it looks young, and in a way, it is. The island formed from lava poured up from a hot plume deep below, fed by the spreading ridge where two great plates pull apart. Yet, under that young volcanic skin, some researchers wonder if something far older may still rest. The idea is quiet, and it is not yet settled. In recent years, a small group of geologists have asked whether a sliver of continental crust might hide beneath parts of Iceland and its surrounding seafloor. They have given this possible fragment a name. Some call it Icelandia. The question is whether it truly exists at all. To understand why anyone would ask, you have to think in cycles. The plates of Earth do not sit still. They drift, collide, and pull apart over hundreds of millions of years. They gather into great supercontinents, then break again into pieces. This long, slow rhythm is sometimes called the supercontinent cycle. It pulses like a heartbeat that takes nearly 500 million years to complete one beat. When the old supercontinent of Pangaea broke apart, the North Atlantic began to open. Greenland drifted one way. Europe drifted the other. Between them, new ocean floor formed dark and basaltic, born from the rising mantle. The standard story says the gap between Greenland and Europe is filled entirely with this fresh ocean crust. Iceland, in this view, is simply a tall volcanic pile sitting on that young floor, made unusually thick by the hot plume below. But some scientists have noticed things that do not quite fit. Iceland's crust is far thicker than ocean crust elsewhere. In some places, more than 30 kilometers down to the mantle. That thickness alone can be explained by extra volcanic activity. Still, a handful of researchers wonder if a strip of older continental rock could be buried inside it, left behind when Greenland and Europe parted ways. If a piece of the old land snapped off and was later coated in lava, we might never see it directly. We would only feel its hidden weight. The competing view is calm and firm. Most geologists hold that Iceland is purely volcanic, with no continental core. The seismic waves that pass through the island, they argue, match what we would expect from thickened ocean crust and not from buried granite. The chemistry of Icelandic lavas in the mainstream reading fits a mantle source. No drill has yet pulled up an ancient continental fragment from beneath the basalt. Without that, the older idea remains a hypothesis. What is fascinating is how the cycles themselves shape this debate. Continents do not vanish all at once. They can stretch like warm clay, thinning out over millions of years until only ribbons remain. Those ribbons can sink, drown, and be paved over by younger rock. The North Atlantic opened slowly, in fits and starts, with pauses and shifts in direction. During those long pauses, slivers of land could in theory be left adrift between the parting giants, like crumbs falling between two slowly opening hands. The pulse of volcanism in Iceland is itself a kind of cycle. The mantle plume below seems to pulse in strength over millions of years, producing surges of lava and quieter intervals. Each surge buries what came before. So if there is anything older down there, it lies under layer after layer of dark stone, stacked through countless eruptions, each one quieting the question a little more. Listening for such a buried thing is hard. Researchers use seismic waves, gravity measurements, and the slow drift of magnetic patterns frozen in cooled lava. Each method gives a blurred picture. The deeper you look, the more the signals smear together. A buried continental ribbon, if it exists, may be too thin and too deeply hidden to show itself clearly with the tools we have today. So the question rests, gentle and unresolved. Is Iceland just a young volcanic island sitting on fresh ocean floor, exactly as the textbooks describe? Or does it cradle the bones of something older, a quiet remnant from the long breakup of a vanished land? Both possibilities live side by side in the science right now. Neither has been proven, and neither has been ruled out. There is something soothing in that uncertainty. The island steams, the plates pull, the mantle pulses in its slow, patient rhythm beneath the sea. And somewhere in that endless cycle of opening and closing, gathering and parting, the answer waits, folded into stone, biding its time, asking only that we keep listening. Between the eastern coast of Britain and the low shores of the Netherlands lies a stretch of cold gray water called the North Sea. Fishing boats cross it every day. Container ships push through its waves. Few of the people aboard those vessels think about what rests beneath the hull. Yet the seabed here is not just empty mud and sand. It is the buried floor of a land that once held forests, rivers, hills, and people. We call it Doggerland. Doggerland is not a lost continent in the grand sense. It was never its own tectonic plate. It does not match the scale of Zealandia or Greater Adria, but it sits in the same family of stories because it is a place that was once dry, walked upon, and is now hidden beneath the sea. It reminds us that lost lands are not always ancient beyond imagining. Some of them vanished only yesterday in the long view of geology. During the last ice age, so much of Earth's water sat frozen in vast sheets that the oceans dropped lower than they sit today. The shallow basin of the North Sea drained away. In its place rose a wide, gentle plain. Rivers from what is now England joined rivers from what is now Germany and Denmark. They wound across marshes and through stands of birch and pine. Herds of red deer moved over the grasslands. Mammoths and aurochs left deep prints in the soft ground. people lived there too. Small bands of hunters and gatherers built camps along the rivers. They carved tools from bone and antler. They fished in the lagoons. For thousands of years, Doggerland was the warm middle of northwest Europe, not the cold edge. Britain was not yet an island. It was simply the western upland of a much larger country with no name. Then the ice began to melt. The sea rose slowly, year by year, century by century. The lowlands flooded first. The rivers widened into estuaries. The estuaries widened into bays. The hills became islands, and then the islands shrank, and then the islands disappeared. Somewhere around 8,000 years ago, the last high ground of Doggerland slipped beneath the waves. A place that had held generations of human life simply became seabed. How fast did it happen at the end? That part remains debated. One theory holds that the drowning was mostly gradual, a soft, patient rise the people could move away from over many lifetimes. Another theory points to a single catastrophic event. About 8,200 years ago, an enormous undersea landslide off the coast of Norway, called the Storegga Slide, sent a great wave across the North Sea. Some researchers wonder if this wave finished what the sea level rise had begun, swamping the final dry islands in a single afternoon. Others think those last islands were already mostly empty, and the wave swept across a land that had nearly finished its long goodbye. The evidence sits at the bottom of the water, half buried, hard to read. What we do know comes mostly from fishing nets. For more than a century, trawlers dragging the seabed near a shallow rise called Dogger Bank have pulled up strange things. Bones of mammoths, antlers shaped into harpoons, flint blades worked by careful hands, pieces of preserved peat, dark and fibrous, that once were the floor of a forest. Each find is a small note from a vanished neighborhood. Doggerland matters to our larger question because it sits as the close cousin of every drowned continent. The same forces that hid Zealandia under shallow seas, the same patient sea level changes that shaped the edges of Sundaland and Beringia, also worked here, just on a smaller stage and on a faster clock. The North Sea is a quiet laboratory. It shows in human time how a landscape can be present and then absent without changing its rock. Maps of the seabed, made with sound waves bounced off the bottom, have begun to reveal the buried river valleys and old shorelines in remarkable detail. We can now trace where a river once curved, where a hill once stood, where a coast once met the morning tide. Yet vast stretches of the floor remain unmapped at fine resolution. Whole campsites, whole groves, whole stories sit untouched beneath the silt. It is a strange comfort, lying in a warm bed, to think of that drowned plain, the slow water moving above it, the cold mud holding its memory, a neighbor land near in space and near in time, asking us softly how many more such places quietly wait beneath the seas we cross without thinking. Tonight we drift south and east to the warm green waters that lap against Indonesia, Malaysia, and the Philippines. The sea here is shallow. In many places, a person could stand on the seafloor and still see sunlight through the water above. This shallow sea hides one of the largest lost lands on Earth. Researchers call it Sundaland, and at its widest reach, it may have been the size of half of modern Europe. Sundaland was not a separate continent in the way Zealandia was. It was the exposed shelf of Southeast Asia, laid bare when the great ice ages locked up so much water that the seas fell by 120 meters. Picture that for a moment. The Java Sea, the Gulf of Thailand, the broad shallow basin between Borneo and Sumatra, all of it dry land. Rivers ran where ships now sail. Tigers, elephants, and rhinoceroses walked across plains that are now coral gardens. The scale is what makes Sundaland one of the extremes among lost lands. At its greatest extent, around 20,000 years ago, it stretched nearly 2 million square kilometers. That is larger than Mexico. It held forests, savannas, and great river systems whose drowned channels can still be traced today by sonar. One of these old rivers, sometimes called the North Sunda River, may have been longer than the modern Mississippi. It gathered waters from Borneo and Sumatra and flowed out toward what is now the South China Sea. Then the ice melted. Slowly, over thousands of years, the seas rose. Sundaland did not vanish in a single dramatic flood, though some researchers wonder if certain stretches were lost in faster pulses. When ice sheets far away in North America collapsed in great surges, others argue the drowning was steady and gentle, a slow creep of warm tide across flat ground. The truth may lie somewhere between, and the evidence is still being read from cores of mud and sand pulled up from the seafloor. Sundaland is extreme in another way. It may be one of the youngest lost lands. While Zealandia sank tens of millions of years ago, and Greater Adria was crushed under Europe long before any human watched, Sundaland was walked by people. Stone tools, fish traps, and the bones of meals lie scattered across what is now the seabed. Our own ancestors lived there. They watched the shoreline move inland, generation after generation, by a hand's width each year. This raises a quiet question that researchers still debate. Did the drowning of Sundaland shape the stories told by the cultures who remember it? Some scholars suggest that the deep flood myths of Southeast Asia, the tales of vanished kingdoms and swallowed coasts, may carry a thread of true memory across 10,000 years. Others find this idea too generous. Flood stories appear everywhere, they argue, because rivers flood everywhere. The question of whether human memory can reach that far remains genuinely open. What is not in doubt is the strangeness of the biology. Sundaland was a single landmass long enough for animals to mix freely across it. When the seas rose, populations were cut apart on different islands. Today, tigers on Sumatra and tigers that once roamed Java and Bali shared ancestors who walked the same dry plains. The same is true for orangutans, for certain monkeys, for many freshwater fish. By studying which species still resemble each other, scientists draw rough maps of the lost geography. The fish themselves remember the shape of rivers that no longer exist. The deepest mystery of Sundaland may be its forests. Pollen pulled from drowned sediments hints at a patchwork of rainforest and open savanna, a landscape unlike anything in the region today. Some researchers think these open corridors helped early humans move across the continent. Others read the same pollen as evidence of denser jungle, with savanna only at the edges. The argument continues. The cores keep coming up, and each one tells a slightly different story. To stand on a beach in Borneo and look out over calm blue water is to stand at the edge of a country that is no longer there. The shallow shelf beneath the waves is one of the largest pieces of recently lost real estate on Earth. It is too shallow to call a true sunken continent in the geologic sense. It is also too vast and too lived in to ignore. Sundaland sits in a category of its own, somewhere between a drowned coastline and a vanished world. How many more such places lie quietly under shallow seas, waiting to be remembered? The question stays with us, soft as the tide, as we move on toward the next lost land. Tonight we move north into a quieter kind of lost land. Not a continent exactly, something gentler. A wide, low country that once stitched two of today's continents together and then slipped away beneath cold gray water. Scientists call it Beringia. For tens of thousands of years, it was simply the ground beneath someone's feet. Beringia stretched between what we now call Siberia and Alaska. At its widest, it may have been around 1,000 miles from north to south. Not a thin bridge then, but a broad plain. A whole country in its own right. The land lay there during the long cold of the last ice age, when so much of Earth's water sat locked up in glaciers that the seas dropped low and exposed the floor of what is today the Bering Strait. The quiet detail here is that Beringia was not a frozen wasteland. That is the picture many of us carry. But the evidence tells a softer story. Pollen grains preserved in old lake mud suggest a landscape of low grasses, small flowering plants, sedges, and patches of dwarf willow and birch. Researchers sometimes call it a mammoth steppe. Cold, yes. Windy, certainly. But alive in a slow, sturdy way, with a sky that probably ran very wide and very pale above the tundra. The small wonders only appear when you look closely. Take a single grain of fossil pollen, smaller than a speck of flour. Under a microscope, it shows a sculpted shell with ridges and pores arranged in patterns unique to each plant family. By counting these grains in layers of ancient sediment, researchers can read the old vegetation of Beringia almost like a slow, page-turning book. One layer holds more grass. Another holds more shrub. Each layer is a season of the land breathing in and out across thousands of years. There are bones, too. The teeth of woolly mammoths, the bones of steppe bison, the small jaws of foals and lemmings. Each fossil carries chemical signals locked in its enamel and collagen. By measuring tiny differences in the isotopes of carbon and nitrogen, scientists can guess what these animals ate and how dry or wet their world might have been. The signals are faint. Reading them is patient work. Yet from these whispers, a portrait slowly forms of herds moving across a plain that no longer exists. The mystery in Beringia is not whether it was there. We are quite sure it was. The open question is what it meant and how it was used. For a long time, the leading idea was that people crossed Beringia in a single, fairly quick wave at the end of the Ice Age, walking from Asia into the Americas through an inland corridor between melting glaciers. That story is still taught in many places. It is simple, and it fits some of the evidence. A competing idea has grown stronger in recent years. Some researchers wonder whether people lived on Beringia itself for thousands of years before moving onward. This is sometimes called the Beringian standstill hypothesis. The thought is that small groups paused in this wide, cold country, sheltered in pockets of shrub and wood, and only later spread south along the Pacific coast by boat or on foot. The genetic patterns of indigenous peoples in the Americas seem, to some scientists, to support a long pause of this kind. Others read the same genetic data differently. The debate is gentle and ongoing. There is a third quiet question. We do not really know what the coastlines of Beringia looked like in detail, because most of those coastlines are now drowned. Any campsites, any hearths, any small carved bones left near the old shore would lie under the modern Bering and Chukchi seas. Cold, dark water sits over them. Sonar maps show old river valleys and shorelines preserved on the seabed, like the faint outlines of a country sketched on a tablecloth. Yet reaching those places and searching them carefully is slow and difficult work. So Beringia stays half hidden. We have the pollen and the bones and the broad shape of the land. We have ideas, more than one of them, about how long people stayed and how they moved. We do not yet have the small things that would settle the question. The shell beads, the worked stones, the soft footprints in dried mud. Those, if they exist, lie under the waves. It is a strange comfort, in a way, to know that a whole country can disappear quietly. Not in fire, not in catastrophe, simply by the slow rise of the sea, while the wind keeps blowing across the grass and the herds wander on toward somewhere new. Long before anyone drew a map of a vanished ocean, people kept finding the wrong fossils in the wrong places. In the high passes of the Alps, in the dry cliffs of the Himalayas, in the limestone of southern Spain, geologists kept stumbling on the shells of sea creatures. Tiny coiled ammonites, the faint outlines of corals, the chalky remains of single-celled drifters that only lived in warm, shallow seas. The stones were thousands of feet above the nearest ocean, and yet they spoke clearly of salt water. For a long time, no one could explain it. In the 17th and 18th centuries, some naturalists believed the great flood of scripture had carried sea life onto the mountains. Others guessed that the rocks themselves had grown in odd shapes by chance. A few brave thinkers wondered if the mountains had once been the seafloor, lifted somehow by forces no one could name. Each idea had its supporters. None of them quite fit. The slow turn came in the 19th century as geologists began to walk the Alps with hammers and notebooks. They traced the layers of stone from valley to valley. They saw that the same sea fossils appeared in long bands stretching from Spain across Italy, through the Balkans, into Turkey, Iran, and beyond into the foothills of the Himalayas. It was as if a single drowned coastline had once curved across half the world. In 1885, the Austrian geologist Eduard Suess gave that lost coastline a name. He called the vanished ocean Tethys, after a sea goddess in old Greek stories. Suess could not yet explain how an ocean could disappear. He had no theory of drifting plates, but he could read the rocks, and the rocks told him that a warm, shallow sea had once stretched between the northern lands and the southern lands, full of life, full of light, full of slow tides tides that lapped against shores we cannot see today. Seuss pictured it as a kind of long, sleepy gulf. Later workers refined his idea, mapping its width and depth from the fossils trapped in the mountains. They found that Tethys had not been one simple sea, but a changing body of water, sometimes broad, sometimes narrow, with islands and reefs and quiet lagoons. They found that it had lasted in various forms for hundreds of millions of years. Still, the deeper question remained. How does an entire ocean simply go away? Where do its coasts go? Where do its waves end up? The answer began to arrive in the 20th century, slowly, in pieces. Alfred Wegener proposed that the continents themselves drifted, slow as fingernails growing, across the face of the planet. At first, he was mocked. By the 1960s, with new measurements from the seafloor, his idea had bloomed into the theory of plate tectonics. Suddenly, the puzzle of Tethys had a shape. The northern lands had drifted south. Africa and India had pushed up toward Europe and Asia. The sea between them had been squeezed, crumpled, and finally closed. The water had drained away. The seafloor had been driven down into the hot interior of the earth, or scraped up into towering ridges of rock. Those scraped up ridges, geologists realized, were the Alps, the Carpathians, the Zagros, the Himalayas. Each great chain marked a piece of the old Tethyan coast, lifted into the sky. The shells in the high passes were not anomalies. They were the last whispers of beaches that no longer existed. And yet, even now, the story is not fully written. Researchers still argue about how many separate seas made up the Tethys system, and in what order they opened and closed. Some speak of a Paleo-Tethys, an older basin, swallowed first. Others map a Neo-Tethys that followed it. There are competing reconstructions of where the small land masses sat within those waters, drifting like leaves on a slow current. The mountains hold the evidence, but the evidence is broken, folded, sometimes melted, and the rocks do not always agree. What we can say is that the discovery of Tethys taught geologists a quieter lesson. Continents and oceans are not permanent. They come and go. A sea can be born, live for 200 million years, and vanish so completely that its only memory is a fossil in a cliff above a village. The Alps you might picture in soft evening light were once a warm seafloor. The dry stones of central Iran once held coral. How many more Tethyses lie hidden in the long story of the earth, their shorelines now folded into mountains we have not yet learned to read. The answer, for now, waits patiently in the scent. Long before Pangaea, long before the continents we know today even had names, the land of Earth gathered itself into a different shape. We call this older gathering Rodinia. The name comes from a Russian word that means to give birth. Because in a way, every continent we walk on today was born from this older mother. Rodinia formed somewhere around 1.1 billion years ago, and it began to break apart roughly 750 million years ago. The strange thing is, almost no one outside of geology has ever heard of it. Most people, when they think of a supercontinent, picture Pangaea. They picture the puzzle piece fit of South America and Africa, the way the coastlines seem to call out to each other. But Pangaea was only the most recent gathering. Before it, there was another called Pangaea. Before that, Rodinia. And there are hints, faint and stubborn, of even older gatherings beneath. Earth, it seems, has been quietly building and breaking the same handful of stones for billions of years. What makes Rodinia so strange is how little of it we can actually see. The rocks that once formed its heart are buried deep inside the cores of modern continents. Geologists call these old, stable interiors cratons, the ancient hearts of the land, made of stone older than almost anything else on the surface. The cratons of Canada, Australia, Siberia, and southern Africa are believed to have once sat together, locked in a single mass. Yet the shape of Rodinia is still argued about. Different research teams draw it differently, and no two maps fully agree. One thing nearly everyone agrees on is that Rodinia sat mostly along the equator. The land basked in warm, shallow seas. Strange, thick mats of bacteria coated the coastlines because complex animals had not yet appeared. The sky may have been a paler color than today. The air held less oxygen. The moon hung a little closer, and the days were a little shorter. Perhaps only about 18 or 20 hours long. A listener standing on Rodinia would have seen no birds, no insects, no flowers, no trees. Only stone, water, sky, and a soft green film of life along the wet places. The truly counterintuitive part is what happened when Rodinia began to break apart. Some researchers suspect that the rifting of this supercontinent may have helped trigger one of the strangest events in Earth's deep past. A period when ice covered nearly the entire planet, perhaps even the equator. Some call this idea Snowball Earth. The theory suggests that as Rodinia split, fresh rock weathered quickly in the warm rains. This pulled carbon dioxide out of the air, which cooled the climate, which froze the seas. Other researchers are not so sure. They argue that the timing does not quite match, and that volcanoes or ocean currents may have played a larger role. The question remains genuinely open. Even more surprising is what Rodinia's breakup may have done for life itself. As the supercontinent cracked into pieces, long, shallow seas opened between the new fragments. Sunlight poured into these warm, mineral-rich shallows. Some scientists wonder if these new shorelines gave early life the chemistry and space it needed to grow more complex. Within a few 100 million years of Rodinia's breakup, the first true animals appear in the fossil record. Whether the timing is a coincidence or a deep cause, no one can yet say. What is strangest of all is that we know Rodinia existed mostly because of tiny magnetic clues hidden inside ancient stones. When rock cools, the magnetic minerals inside lock into the direction of Earth's magnetic field at that moment. By measuring these frozen compass needles in stones from different continents, geologists can work out, very roughly, where those continents once sat. The numbers from cratons far apart sometimes point to the same ancient latitude, hinting they were once neighbors. It is detective work done with grains smaller than a poppy seed, reading whispers more than 1 billion years old. And here is the part that makes even careful scientists pause. There are signs of supercontinents older still. Names like Columbia, or Nuna, or Kenorland, gatherings before Rodinia, stretching back nearly 3 billion years. Some of these older lands are barely more than rumor in the rock. Their outlines shimmer and shift each time a new sample is dated. They are continents we can almost see and almost not see all at once. So when we speak of lost continents, we usually picture them beneath the waves. But some are lost upward, folded into the bones of the land we stand on, hiding in plain sight as the quiet stone beneath our feet. Tonight we drift further back than we have gone yet, past the breakup of Pangaea, past the gathering of Rodinia, into a time so deep that the very idea of a continent was still young. We arrive gently at a name that few people have ever heard spoken aloud. Kenorland, one of the oldest gatherings of land that may have ever existed on this planet. The idea of Kenorland is this: around 2.5 billion years ago, long before complex life, long before the air held much oxygen at all, the small early pieces of crust may have drifted together into a single great mass. Some researchers picture it as a wide, low landscape of bare rock and shallow seas. Others picture several smaller supercontinents forming around the same time, rather than one. The truth sits somewhere in the quiet shadow of stones that are almost too old to read. To understand why Kenorland matters to our mystery of lost continents, we need to think about how everything on Earth plays together. The crust, the mantle, the oceans, the air, even the light from the sun. They are not separate systems. They are one slow symphony, and the continents are only one set of instruments. When Kenorland may have formed, the inside of the earth was hotter than it is today. The mantle, that thick layer of soft hot rock beneath the crust, churned more quickly. Heat from deep within rose toward the surface in great slow plumes. Some scientists believe these plumes helped weld the early pieces of crust together. Others wonder if the early plates simply slid sideways into each other, the way ice flows drift on a pond. The evidence is faint, written in crystals smaller than grains of salt. Once a great mass of land sat above the mantle. It changed the whole planet. A wide continent reflects more sunlight than open ocean. A wide continent also blocks ocean currents that would otherwise carry warmth around the globe. Some researchers think the gathering of Kenorland helped cool the early Earth. Others believe the cooling came from something else entirely. Perhaps the slow rise of oxygen in the air as tiny living things began to breathe out a new gas. That oxygen story is part of the same symphony. As life in the shallow seas released oxygen, the gas reacted with iron dissolved in the water. The iron settled to the seabed in long red bands that we still find in stone today. Some of those bands sit in regions that were once part of Kenorland. So the story of a lost continent and the story of the air we breathe may be written in the same rocks, by the same patient hand. The sun played its part too. The young sun was dimmer than the sun we know now. By rights, the early Earth should have been frozen solid, yet the rocks show liquid water, rivers, shorelines. Something kept the planet warm. One idea is that volcanoes on Kenorland and on the smaller landmasses around it breathed out enough carbon dioxide and methane to hold in the faint sunlight. Another idea is that the clouds themselves were different, thinner and higher, letting more warmth stay near the ground. We still do not know which idea is closer to the truth. Then, perhaps 2.1 billion years ago, Kenorland began to break apart. The mantle shifted. The plumes rose in new places. The land cracked open along long lines, and shallow seas flooded the gaps. The pieces drifted away from each other across a world that no human eye would ever see. Some of those pieces became the cores of the continents we walk on today. The heart of Canada, the shield of Scandinavia, old stones in Western Australia and Southern Africa. They are the quiet grandchildren of a lost world. And so the connection runs through everything. A continent gathers and the climate shifts. The climate shifts and life responds. Life changes the air, and the air changes the stone. The stone records it all in patterns we are only beginning to read. When Kenorland broke, it set new currents flowing in the oceans, new winds turning in the sky, new pathways for evolution to follow. Whether Kenorland was truly one continent or several remains an open question. The rocks are old. The signals are faint. Each new study of ancient crystals adjusts the picture a little. Tonight, somewhere beneath your feet, tiny grain of stone may hold a memory from that distant gathering. It does not speak loudly. It waits, patient, while the symphony plays on, and while we slowly learn to listen. Off the northwest coast of Australia, in the warm, quiet waters that lap against the Kimberley shore, there is a long, deep scar in the ocean floor. Geologists call it the Argo Abyssal Plain. The name sounds gentle, almost poetic, but it marks the place where a piece of earth simply went missing. Around 155 million years ago, a great slab of continental crust pulled away from Australia and drifted north. The sea floor it left behind kept a faint record of the parting. The land itself, though, became one of the strangest puzzles in modern geology. We call that vanished land Argoland. For a long time, researchers assumed it must have traveled north as one tidy piece, the way Zealandia drifted south, or India sailed toward Asia. They expected to find it tucked somewhere beneath the islands of Southeast Asia, waiting to be recognized. The expectation made sense. Continents are heavy, layered things, and they usually move as units. Yet, when geologists looked for Argoland in the rocks of Indonesia and Myanmar and the surrounding seas, they could not find a continent. They found scraps, slivers of ancient crust scattered across thousands of miles, like the pages of a torn book. This is where the mystery deepens. One team of Dutch researchers, working for years on a careful reconstruction, suggested in 2023 that Argoland was never a single continent at all by the time it reached its destination. In their reading of the evidence, it had already broken into long, thin ribbons before it finished drifting away. They called this kind of shattered traveler an argoplago, a scattered archipelago of continental shards. Under their model, the pieces are still there, hiding inside the geology of Sumatra, Borneo, Sulawesi, and the small islands of eastern Indonesia. The continent did not vanish. It dispersed. Other geologists are not entirely convinced. Some wonder whether parts of Argoland slid beneath the edge of Asia and were swallowed back into the mantle, that hot, slow-flowing layer of rock beneath the crust. If that happened, then a portion of the lost continent no longer exists as recognizable land at all. It would have melted, mingled, and become part of the deep churn that feeds volcanoes. Others suggest that Argoland was always made of separate microcontinents loosely joined, and that what we are looking for was never really one place to begin with. Each idea fits some of the evidence. None of them fits all of it. What makes Argoland so unusual is the way it changed during its journey. Most lost continents we discuss tonight kept their shape. Zealandia sank, but stayed whole. Greater Adria crumpled, but left a clear signature. Argoland, by contrast, seems to have transformed in motion, stretching and tearing as it moved. The forces that pulled it apart were patient and immense. Heat rising from the mantle weakened its underside. Tension from spreading sea floor tugged at its edges. Over tens of millions of years, the continent grew thinner in some places and thicker in others, until parts of it cracked along long, parallel lines. You can picture it, if you like, as a slow taffy stretched across an ocean over the lifetime of the dinosaurs. By the time the pieces arrived among the islands of Southeast Asia, they no longer resembled the land that had left Australia. Their rocks still carried the same ancient minerals, the same chemical fingerprints, the same fossils of long-extinct creatures. But their shapes had become unrecognizable. This is part of why finding Argoland took so long. Researchers were searching for a continent. The earth had handed them a scattering. The story is not finished. New mapping of the sea floor around Timor and the Banda Sea keeps revealing little blocks of older crust that may belong to the Argoland family. Each year, more samples are dated, more rocks are tested, more pieces are tentatively placed back into the reconstruction. The puzzle slowly fills in, yet the central question remains open. How much of Argoland survived as recognizable land, and how much was lost forever to the deep recycling of the mantle? We do not know. The numbers in different models still disagree. There is something quietly humbling in this. A continent the size of a small country can break apart, drift across an ocean, and leave behind only hints. The earth does not preserve its lost lands like museum pieces. It rearranges them, folds them, hides them inside other places. tonight, somewhere beneath the green hills of Sulawesi or the warm shallows around Sumatra, fragments of an ancient Australian shore may be resting in the deep. Light has a strange relationship with the deep earth. The mantle, that vast layer of slow hot rock beneath our feet, is utterly dark. No sunbeam has ever reached it. No glow from the surface has ever touched its slow churning currents. And yet, in a quiet way, light is exactly how we learn what hides down there. Not the light of the sun, but the light of other waves, sound waves, seismic waves, the soft pulse of energy that moves through stone the way a ripple moves through water. When a distant earthquake shakes the planet, its waves spread outward in every direction. Some travel along the surface, others dive deep, passing through the mantle, bending and slowing as they meet different kinds of rock. Scientists listen for these waves on the other side of the world. By measuring how long they take to arrive and how their shape has changed, they build a picture of what they passed through. It is a strange sort of vision, a blind kind of seeing, and it is the closest thing we have to shining a light into the buried memory of the earth. This method is called seismic tomography, and the images it produces look almost like soft watercolor paintings of the inside of the planet. Warm patches glow in reds and oranges, marking regions where the rock is hotter and the waves moved more slowly. Cooler patches appear in blues, where the rock is denser and the waves raced through faster. These cool blue shapes, deep beneath the surface, often turn out to be something remarkable. They are the sunken ghosts of old ocean floors, and sometimes the buried remains of continents. When a tectonic plate slides down into the mantle, it does not simply vanish. It sinks slowly, like a heavy blanket folding into warm water. It can take tens of millions of years to descend, and as it falls, it stays slightly cooler than the rock around it. That small difference is enough for seismic waves to notice. Far below our feet, in the soft glow of the tomography map, we can sometimes see the shadow of a continent that disappeared long before the first humans walked the earth. Some of these shadows are huge. Researchers have found what may be ancient slabs of crust lying near the boundary between the mantle and the outer core, almost 2,000 miles down. These pieces sit in a quiet zone of the deep earth, dim and still, far from any sunlight. One idea is that they are the remnants of oceans that closed when ancient continents collided. Another possibility is that some of them are pieces of long-lost landmasses themselves, pulled under during collisions whose details we no longer fully understand. The light of seismic tomography is beautiful, but it is also blurry. The deeper a feature lies, the harder it is to see clearly. Sharp edges fade. Small fragments disappear into the soft glow of background rock. So while we can sense that something is there, we often cannot tell exactly what. A buried continent might look very much like a cold pile of ocean floor. A small lost land might be too faint to spot at all. The picture we have is a candlelit one, full of suggestion and uncertainty. Other tools add their own quiet light to the search. Gravity satellites measure tiny differences in the pull of the Earth across the surface of the oceans. Dense buried rock pulls the sea up by a few extra inches in some places and lets it fall slightly in others. From orbit, these gentle bulges and dips become a map. Magnetic surveys add another layer, sensing the faint stripes of magnetism frozen into ancient seafloor. Each tool offers a different kind of glow. Each one reveals something the others miss. Still, much of the mantle remains a hushed and shadowy place. There are warm plumes rising from deep within, and no one fully agrees on where they begin. There are cold slabs sinking into corners we can barely resolve. There may be entire chapters of continental history written in those depths, waiting for sharper instruments and patient eyes. Some researchers think a few of Earth's oldest landmasses are preserved down there in pieces. Others suspect that most ancient crust has long since melted back into the slow flow of the mantle, its story erased. We do not yet know which view is closer to the truth. The light we use to look is faint, and the rocks we are looking for are very old and very far away. For tonight, it is enough to picture that soft, underground glow. Cool blue ghosts drifting through warm orange currents. Continents that once held mountains and rivers, now resting in the dark, remembered only by the faint trembling of waves. imagine for a moment the sound a fossil might make if it could speak. Not the loud crack of a rock splitting open, but something quieter. A whisper of belonging. A small voice saying, "This is where I lived. This is the shore I knew." For most fossils, that voice matches the map. The bones of an old fish lie in the rocks of an old sea. The leaves of an ancient fern rest in the dust of an ancient forest. But some fossils speak in a language that does not match the ground beneath them. They belong to places that are no longer there. These are the fossils that hint at lost continents. A snail shell pressed into stone on one side of an ocean, matching the snail shell pressed into stone on the other side. A reptile bone in southern Africa that has a twin in South America. Tree ferns from India that share their pattern with tree ferns from Antarctica. Each one is a soft note in a much larger song. And when you listen to enough of them, you start to hear something strange. You hear continents that used to touch. Long before scientists accepted the idea of drifting plates, fossils were already singing this song. People found the same small swimming reptile called Mesosaurus in Brazil and in southern Africa. It lived in fresh water. It could not have crossed a great ocean. So the question hung in the air like a held breath. How did it get to both shores? One answer was that long land bridges once stretched across the sea and then sank away. Another answer was that the continents themselves had moved. For many years, both ideas competed in quiet rooms full of maps and bones. The bridge idea has mostly faded now. The drifting plate idea has won most of the argument. But the fossils still ask harder questions than that. Some of them refuse to settle into any tidy map we can draw. There are tiny sea creatures found in the limestone of southern Europe, whose closest relatives lived along ancient African shores. To explain them, geologists imagine Greater Adria, that drowned continent now folded into the mountains of Italy and Greece. The fossils, in a sense, were the first witnesses. They told us a continent had been there long before the rocks were untangled. In other places, fossils whisper of land that has not yet been found. Pollen grains from old plants turn up in deep sea cores, far from any modern coast. The grains are too heavy and too delicate to have blown across open ocean. must have fallen onto soil. So there must have been soil. So there must have been land. Where exactly that land stood is still an open question. Some researchers connect these grains to known fragments like Mauritia, or to the slow breakup of Gondwana. Others wonder if smaller, unnamed pieces of crust once rose above the waves and then quietly sank again. The sound of these fossils is not loud. It is the soft tap of a hammer on shale, the careful brush of dust from a jawbone, the low hum of a microscope lamp warming up in a museum basement. Whole lifetimes of work go into matching one bone to another across thousands of miles of sea. And even then, the match is rarely perfect. Two fossils may share a shape, but not a date. Two may share a date, but not a shape. The puzzle stays slightly out of tune. There are also fossils that simply do not belong to any continent we know. Old corals in the mountains of Central Asia, sea lilies high in the Himalayas. These were once the floor of the Tethys Sea, that long, warm ocean that closed when India drifted north into the rest of the continent. The fossils now rest in cold, thin air, far from any beach. They are a kind of music played on the wrong instrument. The notes are right. The setting is impossible. What this all suggests, gently, is that the map of Earth is incomplete in a way that fossils know better than we do. Bones and shells and pollen grains keep showing up where they should not be. Each one is a small clue that the land they came from has shifted, drowned, folded, or simply vanished from view. We cannot yet name every continent these fossils once called home. We may never name them all. So the song goes on, very quietly, in drawers and field notebooks and dim museum halls. A song of creatures who lived on lands that are gone. A song that hints at how many maps Earth has worn, and how many of those maps are still missing from our shelves. Beneath the soft language of geology, there is a quieter language made of numbers. The plates that carry continents move at speeds you could almost measure with your fingernails. The fastest of them, the Pacific Plate, drifts at about 10 centimeters a year. The slowest barely manage one. These are the speeds at which mountains are born and oceans are closed. They are the speeds at which whole continents go missing. If you take that gentle pace and stretch it across deep time, the numbers begin to glow. A plate moving 5 centimeters a year covers 50 kilometers in 1,000,000 years. Across 100 million years, it travels 5,000 kilometers. That is enough to carry a fragment of crust from one hemisphere into another, enough to slide a small continent under a larger one and erase it from view. The mathematics of slowness is the mathematics of disappearance. Researchers use these numbers to run the tape of Earth backward. They take the present position of the continents, measure the magnetic stripes preserved in the ocean floor, and rewind the motion at the rates the rocks themselves record. The seafloor near a spreading ridge holds a kind of barcode, with bands of normal and reversed magnetism laid down as the molten rock cools. Counting those bands gives an age. Knowing the age and the distance gives a speed. From speed and direction, the whole slow choreography can be reconstructed. This is the elegance behind the search for lost continents. The arithmetic is simple, even if the data is hard to gather. Spreading rates, subduction rates, the angle at which one plate dips beneath another. Each can be turned into a number, and each number tightens the picture. When the math of Greater Adria was finally worked through, 10 years of computation produced a single animation of a continent vanishing beneath southern Europe across 240 million years. Still, the equations leave room for disagreement, and this is where the silent competition between theories lives. 2 research groups can take similar data and arrive at different reconstructions of the same lost land. One model might place a fragment on the northern edge of an ancient ocean. Another might place it on the southern edge. Both can fit the rocks, the magnetism, and the fossils within the margin of error. The numbers narrow the possibilities without always choosing among them. There are ratios in this work that feel almost musical. The thickness of continental crust averages around 35 kilometers. Oceanic crust averages around 7. That difference, roughly 5-to-1, is part of why continents float higher and oceans sit lower. It is also why a thinned, stretched continent like Zealandia can sink below sea level while still being, by composition, a continent. the ratio is small. The consequence is an entire hidden landmass. Density plays its own quiet part. Continental rock has a density of about 2.7 grams per cubic centimeter. Oceanic rock comes in heavier, near 3.0. That tenth of a point difference decides which plate slides under and which rides over. It decides which continents survive and which are pulled into the mantle and remade. Even the deep timing has a rhythm. The supercontinent cycle, the long gathering and scattering of the world's landmasses, seems to repeat roughly every 400 to 600 million years. Rodinia formed, then broke apart. Pangaea followed. Some researchers suspect a future supercontinent will assemble in another 250 million years. Others propose different geometries, different centers of gathering. The cycle is real. The next chapter remains a debate written in numbers that have not yet settled. Gravity gives another set of equations. Satellites measure tiny variations in Earth's gravitational pull as they orbit overhead. A buried block of dense rock tugs on them a little harder. A buried block of light continental crust tugs a little softer. From these whispers, maps are drawn of structures kilometers below the surface, structures no human eye will ever see. The signal is faint. The math turns the faint signal into a shape. What remains beautiful and unresolved is how much of Earth still escapes these calculations. Vast stretches of the deep ocean floor have only been measured at low resolution. The mantle hides shapes that gravity can hint at, but not fully draw. Two competing reconstructions of a lost continent can both pass every numerical test currently available and still describe different worlds. The arithmetic is honest about its own limits. For tonight, it is enough to picture the equations as a soft hum running underneath the rocks. Slow speeds, small ratios, long cycles, a simple set of rules patiently rearranging a planet, and a question of how many continents those rules have quietly tucked out of S. To find a lost continent, you must learn how to listen. The ocean does not give up its secrets easily. The deep seafloor is darker than any forest at night, colder than the highest mountain, and pressed down by miles of heavy water. No human eye has ever swept across most of it. And yet, slowly, patiently, we have learned to map these hidden places using sound and gentle nudges of gravity from far above. The first tool is sonar. A ship moves across the surface of the sea, sending pulses of sound down into the dark. The sound travels through the water, strikes the seafloor, and bounces back. By measuring how long each echo takes to return, the ship builds a picture of the shape below. A shallow ridge returns its echo quickly. A deep trench takes much longer. Ship by ship, line by line, the soft hills and steep cliffs of the underwater world begin to appear on the screen, drawn in faint shades of blue. But sonar is slow. A single research ship, sweeping back and forth, can only map a narrow ribbon at a time. Even after a century of careful work, more than 3/4 of the deep seafloor remains unmapped at high detail. The lost continents hide in this enormous, quiet gap. Zealandia took decades to confirm because the ships had to crisscross a region larger than India, far from any harbor, often through rough southern seas. So we turned to a second tool. Far above the waves, satellites circle the Earth, measuring something gentler than sound. They measure gravity. The seafloor is not flat in any simple way. A buried mountain has more mass than the water around it, so it pulls the ocean's surface up by a tiny amount, sometimes only a few centimeters. A deep trench does the opposite, letting the surface settle slightly lower. From orbit, sensitive instruments can detect these soft swells and dips on the open sea. From them, scientists draw a kind of shadow map of the seafloor below. This is how the rough shape of Zealandia first came into focus. The gravity maps showed a wide plateau in the southwest Pacific, sitting lower than the deep ocean basins, but higher than the abyssal plain. The shape suggested continental crust, thicker and lighter than the dense rock of the ocean floor. Later, drilling ships pulled up samples that matched this guess. Stones from below the waves carried the chemistry of a continent, not of a sunken sea. Yet the system that allows this listening is remarkably fragile. Sonar relies on the steady speed of sound through seawater, and that speed shifts with temperature, salt, and depth. a warming layer near the surface can bend the sound waves and blur the picture below. Satellites depend on a thin shell of atmosphere clear enough to send signals through, and on an orbit kept stable by careful calculation. The whole arrangement only works because Earth holds its conditions within a narrow band. The air stays thin but breathable. The oceans stay liquid. The poles stay cold enough to anchor the planet's slow rhythms. It is worth pausing to notice how unlikely this is. If Earth were a little closer to the sun, the oceans might boil away, and there would be no water through which to send sound. A little farther, and the seas would freeze into thick caps, sealing the seafloor under ice. The atmosphere is only a few dozen miles deep, a soft skin over a stone world, and through it we send pulses of radar and laser light to measure tides only a few centimeters high. Lose that skin, and the satellites would have nothing to look through. Even the magnetic field plays a quiet part. It shields the upper atmosphere from being stripped away, and it leaves faint patterns in the cooling lavas of the seafloor. By reading those magnetic stripes, geologists can tell how old a piece of ocean crust is and how fast it spread from a ridge. This is one of the ways we know which continents have been wandering and where their lost pieces might lie. So the search for vanished lands depends on a delicate chain. Quiet ships above quiet seas, cold satellites in steady orbits, an atmosphere thin enough to see through, thick enough to breathe, oceans liquid enough to carry sound, a magnetic field strong enough to keep the record intact. Change any one of these by very much, and the listening would stop. We do not know how many lost continents remain hidden in the silence. We only know that the listening is possible at all because Earth, for now, holds itself in this gentle balance. Somewhere off the coast of Alabama, divers swim through a forest that has no business existing. Old cypress trees rise from the seabed, their stumps still rooted in the soft mud where they grew tens of thousands of years ago. The wood is so well preserved that when you cut into it, you can still smell the sap. The trees grew in open air on dry ground when the sea was far away. Then the water came, slowly, patiently, and covered them. That drowned forest is not alone. scattered along the edges of nearly every continent in shallow bays and on broad shelves lie the remains of woodlands that once stood under the sun. Stumps off the coast of Wales, sunken pine roots near Japan, ancient peat layers off the shores of the Netherlands, holding tree pollen from forests that no living person has ever walked through. Each one marks a coastline that used to be inland. Each one is a small, quiet piece of a continent that has been partly lost. These drowned forests sit at the heart of an open question. We know in broad strokes that sea levels rose when the great ice sheets melted at the end of the last ice age. We know that vast stretches of land, Doggerland, Sundaland, Beringia, the wide shelves around Australia, went under. What we do not know in fine detail is what those lands looked like. We do not know how thick the forests were, how the rivers braided across the plains, which animals followed which valleys. The water came up and erased the map before anyone could draw it. The forests are stubborn witnesses, though. The wood holds rings, and the rings hold weather. By reading the rings of a sunken stump, researchers can sometimes pull out the climate of a single summer that ended long before the pyramids were built. The peat holds pollen, and the pollen names the trees. Oak, hazel, birch, pine. From these scraps, scientists try to rebuild a green world that the ocean swallowed. But the picture stays blurry. One question that remains genuinely open is how fast the drowning actually happened. Some evidence suggests slow, steady creep, a few millimeters a year, almost gentle. Other evidence hints at sudden pulses, when meltwater from a collapsing ice dam rushed out and lifted the global sea by meters within a human lifetime. Both ideas have supporters. Both fit some of the data and not the rest. The drowned forests, with their growth rings and their salt-soaked roots, may eventually tell us which is closer to the truth. For now, the question stays unsettled. There is also the puzzle of why so many of these forests are so well preserved. Wood normally rots. Bacteria and worms and tides should have taken these stumps apart long ago. Yet here they stand, soft and dark, still recognizable as trees. One idea is that the mud sealed them off from oxygen quickly, slowing the decay almost to a stop. Another idea is that certain peat chemistries, rich in tannins, act like a natural pickling fluid. The two ideas are not enemies. They may both be true in different places for different reasons. The full chemistry of how a forest becomes a fossil garden under the sea is still being worked out, and there are forests we have not found yet. Sonar maps of the continental shelves are getting sharper each year, but most of the shallow seafloor has never been examined tree by tree. Somewhere off Patagonia, off the Russian Arctic, off the long curving shelf of West Africa, there are almost certainly more woodlands waiting in the dark. We do not know how many. We do not know how old the oldest one will turn out to be. Each new discovery quietly resets the map of what the lost coastlines once held. What lingers when you sit with these drowned forests is the strangeness of scale. A continent does not have to sink dramatically to be partly lost. It only has to lower its shoulders a little, or let the sea climb a little, and whole landscapes slide out of reach. The lost continents we have spoken of in earlier sections, Zealandia, Mauritia, Greater Adria, Argoland, are grand and ancient. The drowned forests are small and recent, yet they belong to the same family of questions. Land is not as fixed as it feels under our feet. Somewhere off Alabama, the cypress stumps still stand in the dark water. They do not answer. They only wait, soft and patient, while the tide moves above them and the slow work of understanding goes on. Long before satellites mapped the ocean floor, long before anyone had heard the words plate tectonics, people told stories about lands that were no longer there. Almost every coastal culture seems to have one. The Greeks spoke of Atlantis, a great civilization that sank in a single day. Sailors in the South Pacific shared songs about islands their grandparents could walk to, now hidden beneath the waves. In southern India, old Tamil poems describe Kumari Kandam, a wide southern country swallowed by the sea. In Welsh and Breton tradition, the kingdom of Lyoness lies somewhere off the coast of Cornwall, its church bells still ringing under the water on quiet nights. It is tempting to dismiss these tales as pure invention, and yet the sea really has risen. Coastlines really have drowned. Forests really do lie beneath the tides. The question that lingers, soft and unresolved, is how much of what we call legend might be a faint memory of something true, passed down through hundreds of generations, like a worn pebble handed from grandparent to child. One school of thought holds that these stories are simply natural responses to a changing world. A village notices the sea creeping in. A storm takes the lowlands. Over time, the loss grows in the telling until a single farm becomes a kingdom and a single bay becomes a continent. By this view, the legends are emotional truths, not geological ones. They speak to grief, to memory, to the human habit of imagining better lands behind us. Another view treats some of these stories as compressed history. Doggerland, the drowned plain beneath the North Sea, was once home to families who fished and hunted there. When the waters rose at the end of the last ice age, those families moved inland and carried their memories with them. It is at least possible that some of our oldest flood tales preserve a faint thread of that slow loss, stretched and reshaped across thousands of years. Researchers have noted how widely flood stories appear in cultures whose ancestors lived near rising post-glacial seas. Whether that pattern is coincidence or a kind of cultural fossil remains an open question. Then there is Candom, often raised in the same breath as the discovery of Mauritia beneath the Indian Ocean. The legend describes a southern Tamil homeland lost to the sea long ago. The geology tells of a much older, much deeper story. Fragments of ancient continental crust hidden under volcanic rock, drowned tens of millions of years before any human walked the earth. The two stories do not match in time. They cannot describe the same event, yet some wonder whether the legend grew in part from the simple human observation that the southern sea is strange, that islands rise and fall, that the world used to be different. The connection, if any, may be poetic rather than literal. The mystery is whether poetry and geology are ever truly separate. Looking forward, the lands we walk today will join the long list of vanished places. In 1,000,000 years, coastlines will look unfamiliar. In 10 million, mountain ranges now rising will have new shapes, and seas now closed will have opened. in 100 million years, some researchers suggest, the continents may gather again into a single great mass, sometimes called Pangaea Proxima, sometimes Amasia, sometimes Orica, depending on which model of plate motion one trusts. The names differ because the futures differ. The question of how Earth's plates will choose their next dance remains genuinely open. In 1 billion years, the sun will be brighter and warmer, and the oceans we know may be much smaller or gone. New continents will form from the bones of the old, lifted from sediments that include our cities, our roads, the bottles we threw away last summer. Somewhere in that far future, perhaps, a thinking creature will stand on a cliff made of compressed 21st century sand and wonder what came before. They may invent legends. They may dig for evidence. They may find both and not be sure which is which. For now, the legends sit beside the science like two old companions who do not always agree. The science gives us Zealandia, Greater Adria, Mauritia, Argoland, confirmed losses, mapped in patient detail. The legends give us Atlantis, Lyoness, Cumoricandum, mu losses confirmed only in story. Between them lies a wide, quiet territory where memory and stone may sometimes touch, and where the listener tonight is free to wander without needing to decide. The lands beneath the waves keep their counsel. The lands beneath the songs keep theirs. We are still learning to read both. Step back now, as far back as the mind can travel, and look at the planet beneath your feet from a great quiet distance. The continents you know, the ones drawn on every map you have ever seen, are only the latest arrangement of a much older story. They are a single still frame inside a film that has been playing for billions of years. The rocks under your home were once part of other lands, lands that no longer exist by the names we use today. And the lands we walk now will, in time, become lost continents too. This is the slow truth that sits beneath everything we have wondered about tonight. Earth is not finished. The plates are still drifting, a few centimeters each year, about the rate your fingernails grow. In 50 million years, the Atlantic Ocean may be wider, or it may begin to close. Africa is pressing north into Europe. slowly erasing the last traces of the old Tethys Sea. Australia is moving toward Asia. The Pacific is shrinking. One possibility held by many geologists is that all of these motions will gather the continents back together into a single supercontinent. Some call this future land Pangaea Ultima. Others picture a different arrangement, sometimes called Amasia or Orica. The truth is, the deeper future remains an open question, shaped by forces we can only partly model. And yet, even this enormous story is a small chapter in a much larger one. The atoms in the rocks beneath you, the iron and the silicon, the oxygen locked into stone, did not begin on Earth. They were forged inside stars that lived and died long before our sun existed. The calcium in your bones, the iron in your blood, the carbon in every leaf and every coral reef, all of it was cooked inside ancient stellar furnaces and scattered across space when those stars came to their quiet ends. The dust gathered. It became our solar system. It became this planet. It became the continents that rise and fall. So, when we speak of a lost continent like Zealandia or Mauritia, we are really speaking of starlight that took a particular shape for a little while. The granite of Greater Adria, now folded into the limestone cliffs of Italy, was once seabed, and before that mineral grains, and before that the slow gift of dying stars. The sands of sunken Sundaland, now hidden under warm tropical water, carry the same deep memory. Every grain is older than any continent. Every atom has been many places. This is why the question of how many continents Earth might still hide is, in a sense, a question about ourselves. We are made of the same material. We are part of the same long arrangement and rearrangement. The bones of vanished lands are the bones we share. The minerals that built Rodinia, that ancient supercontinent from 1 billion years ago, still circulate through the planet today, lifted by volcanoes, ground down by rivers, carried by wind, settled into new shores. Nothing is truly gone. It is only moved. Some researchers wonder whether life itself may have first taken hold on coastlines that no longer exist, on the edges of continents we have not yet found. Others think the cradle of life was in deep ocean vents that have long since been swallowed back into the mantle. Both ideas remain open. Both ask us to imagine a planet that has forgotten more about itself than it remembers. And we, walking softly across the current arrangement of land, are a brief part of this remembering. The maps in our books will not match the maps of the far future. The cities we build sit on plates that are slowly carrying them somewhere new. The mountains around us were once seabeds. The seabeds beneath the ships of the world were once mountains. Stone becomes water, becomes stone again. Continents rise. Continents drown. The pattern continues, patient and unhurried, indifferent to our short lives, and somehow, in that indifference, deeply comforting. For tonight, it is enough to know that you rest on the back of a moving thing. Enough to know that the ground beneath you carries the memory of lost lands, and that one day this very ground will be a memory in turn. Enough to know that you are made of the same patient atoms that built every continent that ever was, and every continent that ever will be. There is a quiet kinship in that, a sense of belonging that needs no map. Let your thoughts rest there, in the long, slow breath of the planet, and in the older, deeper breath of the stars that made it. So here we are, at the soft edge of the night, where the words begin to slow and the eyes grow heavy. We have wandered together across a planet that hides more than it shows. We have drifted above sunken stones in the Indian Ocean, walked the ghost plains of Doggerland, and traced the long, quiet curve of Zealandia beneath the waves. And still, after all of it, the question remains as open as it was when we began. How many lost continents does the earth quietly hold beneath her skin? We do not know. That is the simple, beautiful truth of tonight. The maps in our books look finished, with their 7 familiar shapes and their tidy blue oceans. But the maps are not finished. They are sketches drawn at the surface of something far deeper. Beneath each one, the rock remembers more than we have learned to read. Some researchers believe we have found most of the large hidden pieces already. They point to the steady improvement of sonar, the patient eyes of satellites, the quiet listening of seismic stations across the globe. Others wonder if whole fragments still wait in the dark, tucked under thick layers of seafloor mud, or pressed so deep into the mantle that no instrument can yet sense their shape. Both ideas are reasonable. Neither is settled, and the silence between them is part of the wonder. Picture the planet for a moment, just as she is tonight. A pale blue sphere turning slowly in the dark. The oceans catching the soft light of the moon. Silver across the Pacific, gold along the edges of the Indian seas. Continents standing quietly above the water, their mountains dusted with snow, their forests breathing in the long, slow rhythm of the night. And beneath all of it, the unseen stone, drifting at the speed of growing fingernails, carrying ancient memories no human eye has ever read. Somewhere under the waves of New Zealand, the long ridge of Zealandia rests in its blue twilight. Somewhere beneath the rolling hills of southern Europe, the pressed bones of greater Adria lie folded into mountains. Somewhere off the coast of Western Australia, the puzzle of Argoland still waits to be matched to its missing pieces. None of these places are gone. They have only changed form. They have only learned to be quiet. It is a gentle thought when you sit with it. Nothing on earth is truly lost. The continents we call lost are simply resting in places we have not yet learned to look. The forests that once grew on Doggerland still live in the pollen grains buried in the North Sea floor. The shores of Sundaland still live in the memory of the coral that grew along them. The grains of ancient Mauritia still live in the volcanic sands of a small island far above. Stone keeps its records longer than any of us can imagine. And so the mystery stays open, and that is its gift. We may know more in the years ahead as new instruments listen more carefully, as new ships chart what older ships could not see. Or we may live our whole lives with the question half answered, leaving the rest for those who come after us. Either way, the earth is patient. She has been keeping these secrets for billions of years. She is in no hurry to share them all at once. Let your breathing slow. Let your shoulders rest into the quiet. The planet beneath you is turning, as she always does, carrying her hidden continents through the long, soft dark. Somewhere a glacier is creaking. Somewhere a wave is folding onto a moonlit beach. Somewhere a desert is cooling under a sky of stars. And somewhere beneath all of it, the old stones are drifting in their slow and gentle dance. You are small, and the world is vast, and that is a kind of comfort. The mountains will rise without you tonight. The oceans will hold their depths without you watching. The lost continents will keep their long sleep beneath the sea, and they will not mind if you sleep too. Whatever questions remain unanswered, they will still be here in the morning. They will still be here 1,000 mornings from now. There is time. There has always been time. Rest now. Let the wondering settle into something soft. Let the mysteries we have shared tonight become the quiet shapes of a dream. The earth is older than worry, deeper than hurry, and she holds you gently, just as she holds her hidden stones. Subscribe for a brand new Earth topic every night. One tap, and something wonderful is waiting for you tomorrow. Sweet dreams.